Okay, so some people had confusion about the calculator thing, so I'm saying that again. So in calculator, consider this as a requirement. Don't think about physical calculators, think about creating a calculator in your browser, okay? So in your browser, you are creating something like this, and you have, say, calculator written on top, and you have 3 buttons over here or 3 options. Now, one option says that you're creating a scientific calculator. You want to use a scientific calculator. The other one says that you want to use a normal calculator. And the other one says that you want to use a, say, financial calculator. Okay. Now, there are 3 types of calculators. For all of this, now when you click scientific or normal or financial, what is going to happen is a new display is going to open, correct? A new screen is going to open. And how is it going to look? There's going to be a display over here, and then there are going to be some keys, right? Like key 1, key 2, key 3, key 4. Like in a normal calculator, it will be just plus, minus, and all of that. In scientific, probably there will be log, integration, and scientific things will be there. In financial, integration and all will be more. Plus in display, like sometimes graphs and all are there in financial and all. So the display is different, the keyboard is different, correct? So if I think about it, just think of this case, like how would you create the display and the keyboard? So basically think of it like this. Now, firstly, what problem are we trying to solve? Think of it like this. So first you are trying to make 2 things. One is like, say, display. Second is, say, keypad or keyboard or whatever you want to call it. Now these are supposed to be of 3 kinds. One is the scientific one is the normal one, and then one is the financial one, correct? Similarly, my keypad also, it has to be of 3 types: scientific one, normal one, and financial one, correct? Now I have to create all of this. So how will I do this? Right now you should be thinking of factory of like family of similar products, right? Similar products, family of that, right? So that is why I would use an abstract factory. And then I would probably have scientific calculator factory, and then say normal calculator factory. And then I would have a financial calculator factory. Did any of you saw this problem like this? Because I saw a lot of people saying that, it is not possible. We are overfitting it. See, I'm not saying this is right or wrong. I am saying because a lot of people kept saying that it is not possible. But you are supposed to think of possible solutions, like, what would be the case? What are the different cases possible? How is, like, why are we doing this? If I have suggested, like, yes, we already gave the hints on Discord also, some people are saying, because we wanted you to think about it. So scientific calculator factory will do what? It will create scientific display, scientific keypad. And again, we are talking about creational design pattern. So talk about creating the display, talk about creating the keypad, correct? Similarly, normal one will create the normal ones, and the financial one will create the financial ones. Remember, we made a lot of these diagrams when we were discussing abstract factory design pattern? Yes? So now that is why I want you all to keep thinking when we talk about homework and all of this. So please, I want such discussions to happen. I was expecting at least one person to share like this diagram, at least one person to share this on Discord, but no one did. So can I expect better participation and, better thought processes for homework? Yes? Okay, cool. Thank you. Continuing from what we left yesterday. So we were talking about which design pattern? Which design pattern were you talking about yesterday? Singleton? Yes. So Singleton does what? We have to make sure that there is only one instance of the object, correct? So basically we will have a getter. We'll have like, let me call it, say, get instance. It can be get logger or get config or get db or whatever. And inside this, what are we doing? We are saying that if the instance is equal to null, only then you do it, you create it. So something like this you can do, that instance equal to, say, new object, whatever it is, logger or whatever, right? So I'm just writing Singleton for now. So only if this is the case, it is going to create. Otherwise, what am I going to do? I'm just going to return whatever instance was there. So this makes sense to everyone that only if it is null, that is only for the first time I'm going to create it. Otherwise, I'm going to return whatever was there. This makes sense to everyone, correct? And we are returning the singleton type. We also talked that we can make this static so that I can just call this instance from like the class itself, and it won't belong to an object of the class. It will belong to the class itself. Similarly, the instance also, because we don't want it to be associated with a particular object, right? Anywhere I want this instance to be used, I want it to be used simply like static getter will be there at get instance. Okay, so this much is clear, right? Now we are talking about multi-threading scenario. So everyone full focus over here. Okay. So what are we doing is that we have two threads now. Okay. One thread comes very nicely, comes over here. Suppose this is thread T1. Okay. Comes and sees that instance is null. Very good. I will start creating. Okay. Now, by the time this T1 started creating, okay, it is not done creating right now. There's another thread that comes T2. It says that instance is still null, correct? Because see, T1 is not done creating this. It is not done creating this. Almost like milliseconds of difference. T2 comes, sees that it is null. It also starts creating. So basically now two threads are inside this and two instances will be created. And I don't know how many of you have watched this, but in the YouTube video that I have, like the Singleton YouTube video, I've actually demoed this. Okay, so you can actually create it like in any language that you do and that you use. So Java, C++, you can do in both. Just create two threads and just write this code. Write this code only. Okay, just write this. And in two threads, like in one thread, try creating the instance, and another thread, try creating the instance. You will see that the number of instances will be more than one. Not maybe in once and twice, but it will happen. You will be able to replicate it. Okay. So this is a very famous case, like in Singleton, and you should be knowing this. Again, in terms of interviews, in terms of daily work also. Simple Factory and Singleton, two extremely important regional design patterns that you should know. You have to know. Okay, so the concept that I'm going to cover now, you just cannot miss it. It is extremely important in terms of interview and in terms of daily work. You need to understand it. So I want full attention right now. Okay, no bakwas in the chat. Full attention over here. Okay, so we understood that if there are two threads, right? So if there are two threads, two instances will be created. Everyone is able to view this much, right? So if there is one thread that comes, gets inside the if condition, another thread that comes, creates this. Yes? Can I get yes that you are able to understand that what is a multi-threading scenario? Everyone is able to understand? Okay. So whenever multi-threading scenarios come, no, very simple solution is that you put a lock. What that I will put a lock over here and I will unlock it. Now, there are different ways of putting the lock. There are different ways of locks in Java, C++. Don't worry about any of that. What are we talking about? We have to put a lock. We have to unlock it. You can use a mutex. Okay. Don't worry about the details about how are we going to do it. Just understand that when we put a lock, only one thread. So if there's a lock, only one thread is going to get inside. Create this, nicely gets out. Even if second thread comes, because there is a lock, it is not going to get inside this. Understood? This much makes sense? Yes? Yes or no? Everyone understood this? That firstly, we were doing what? We were just using this much. Then we understood this is not thread safe. Very nicely, we just put a lock, we just put an unlock. Very simple stuff, right? Now the thing is that these locks are expensive. And we should think about that we have to create this instance only once. Only once. Once get instance is done, once we create the instance, we will actually never get inside this lock. Okay, actually this return statement should be outside after this, because return anyway we have to do, sorry. Return anyway we have to do, right? So return statement should be outside. It should be over here, return instance. See, we are going to be executing this only once. the one time we create the instance. Every other time, we are going to just return the instance. Correct? So yes, it affects the performance. So it is not a good thing that every time I say get instance, we are getting into the lock, even though the instance is already created. The condition is actually not going to happen. We are not going to get into the race condition. But still, again and again, we are creating the lock. Seems stupid, right? Yes or no? Okay, let me say this part again, because this is extremely important, guys. You have to understand this, okay? So the function is get instance. What was the first thing that we did? That if my instance is equal to null, you create a new instance. So basically, instance will be equal to new singleton. And I will just return this instance, right? Then we said that a race condition can happen. Two threads can come and they might try to assess try to get inside this if condition at the same time, like milliseconds ka difference, microseconds ka difference, correct? So race condition, so we have to put a lock. So what did we do? We put a lock over here and unlock over here. Simple. Now I said that this is very expensive and we need to put this lock only once, only that one time when this new is going to happen. Once this new has happened, our instance is always null, right? We do not need to put the lock. So what I do now is I put another check over here that if instance is null, then only you put the lock, you do this, you put the checks and you go ahead. And this concept is called double check blocking. So why double check locking? Because we are putting two checks, right? If instance is null, if instance is null. Let's see again, why are we doing this? See, the first time we come to this, the first time we say that the instance is null, we are going to put a lock. Okay, so even if two threads come inside this, it is fine because there's a lock inside, right? So suppose T1 and T2 come. So suppose now T1 came over here, got inside this, T2 also got inside this. So that was the problem that we were trying to solve, right? In multi-threading, T1 and T2 got inside this, but inside there is a lock, right? So only T1 will go ahead, nicely create it, and T2 will wait till unlock happens, right? And when the unlock happens, T2 is going to check again. Is it null? By that time, T1 must have created, right? So now they will never be the case when two instances will be created. This is called double check locking. Yes? Now let me look at the comments because we can remove the second if condition. No, we cannot. We cannot remove the second if condition. And that is the point that I'm trying to make over here. See, see it very carefully. We cannot remove the second if condition because see right now T1 and T2 at the same time can get inside. So once we put the lock, T1 must have created. But once it unlocks, T2 is still going to come inside, right? And if this is not there, T2 will create again. So we need both the checks. This outer check is to make sure that we don't put a lock every single time. Inner check to we need it. Outer check is so that we can make it more efficient. Yes? Yes, there are many other ways to handle singleton, but this is a very, very famous way that you need to know. Double check locking. Everyone understands what problem we are trying to solve, how we are trying to solve it. This code that you are seeing, double check locking, I have used it so many times I cannot tell you. You open the Swiggy Zomato code or the Uber Ola code on my GitHub, you will see every single manager that I have used. Like there's a restaurant manager that takes care of all the restaurants, or there's a rider manager that takes care of all the riders. I want a singleton object, a singleton class, only one instance of the object. I will use singleton design pattern and you will see this code over there. Double check locking. Yep. Yes. As Manijan mentioned, we are talking about multiple threads at once accessing the block. So all the threads wait until thread one creates an object. So yes, if there is a lock, obviously lock means that the threads are going to wait. So unless this lock is unlocked, all the other threads are going to wait. That is the whole point. Okay. quickly repeating it so that you don't forget, because it is extremely important and you need to remember it. You need to understand this properly. Quickly covering it again. There is a get instance. We are returning singleton object. So if my instance is null, I am going to create a new one. Guys, whoever has not understood, please pay attention over here. I'm going to say new singleton. Okay. Now what am I going to do? Outside, I'm just going to return the instance. Now I said this is not thread safe. To make it thread safe, I put a lock. That okay, lock over here. You can use mutex. So mutex.lock, mutex.unlock. Okay. Once I put the lock unlock, I realized that this is very expensive. I'm going to need it only once. When am I going to need it? When I create this one instance. So what did I do? I put another check over here. If instance is null, only the first time when it is getting created, I'm going to do all of this. Otherwise, I'm just going to return. Double check locking. Okay. Now, everyone has understood this. Can I get yes or no for this? Everyone has understood this part, double check locking. Yes. Can we have the lock inside the if condition? Lock inside the if condition. Then the check will be there, and then after that you will be creating. So then if you put lock over here, when the second thread comes, it will miss the check, no? Right? So second thread has to check like after unlock, right? So T1 and T2 come. So T2, once it has done unlocking, once T1 is done unlocking, T2 should come over here and do the checking again. Yep. Okay. Okay, cool. Okay. Now, I know a lot of people are thinking, do we need to know all of this? There are many ways of handling this. One way, see, there is something called early or eager initialization. Okay, so let me talk about this. Early or eager initialization, which means that when my system is coming up, say I am designing Swiggy, Zomato, or Uber, Ola, or whatever it is, when my system comes up, irrespective of the fact, if I have started using logger, config, DB instance, whatever, I will nicely instantiate it. Like I will instantiate the logger, the config, the DB instance, like all my singleton objects, I will create it. And right now there is only main thread, right? There is no other thread also, right? So right now there is only main thread. So what am I going to do? I'm going to just put that simple check that if instance is equal to null, then you return the same thing. Only one check is enough. And even this, if it is not required because you're doing only once, right? So you can actually just do this because you know you're doing it only once. So you can just do return new singleton or new logger or new whatever. Because you know it is the main thread. There's no other thread that is using it currently. You know this is the only time when this object is going to be created. Rest, all the places get instance is going to be done, right? From there, you can either do get instance or you can put a check over there and do it. But you do realize that you will not need double check locking if you do it at the early stage, eager initialization. Everyone understands this much? Yes or no? Yes? No? Okay, people are saying no. Okay. See, when my system comes up, when my system just comes up, I have not created multiple threads right now. There's only one main thread that is running, no multiple threads. Okay. I know that these are my singleton objects, like these are my singleton classes. I will need their instances. And I want one instance of logger, one instance of config, one instance of DB instance. And why do we do double check locking? In order to handle the multi-threading scenarios, correct? Now I am saying that you do it in the starting itself. Don't wait that when I'm going to need it, I'm going to create the instance. When you are sure that there's only one thread, you create it. So in that case, what you will have to do, you can simply do a get instance. And inside that, a simple check will be there. That if instance is equal to null, there are two ways of doing this. Let me tell you what. So there is, So there is instance equal to new singleton. And then you're going to, like outside, you're going to do return instance. So if you want to use the same function everywhere throughout, even when you create 2 threads, 10 threads, even when you start using multi-threading, it is fine. You can still use it because you've already created the instance. So you will never get inside this if condition. You will never ever get inside this if condition. You will always return the same instance. Yes, makes sense? Does this much make sense? That if we do early initialization, in the starting, if I create my object and keep, when I use it later, suppose there are 10 threads, there are these many threads, I don't care. At that time, I will just do this return instance. I will never get inside this if, because my instance will never be null. I have created one instance. Correct? If we have multiple clients and multi-thread, Money, I am talking about the case when you have one thread, you have just started the system. That is what I'm talking about. When you have one thread, you have just started the system and not created multiple threads. So you are doing this. Why? So that you don't have to take care of multi-threading. This is called early or eager initialization during application startup. Correct? Now, can I get yes? That have you understood what am I trying to say by early or eager initialization? We'll compare it. Yes? Guys, can I get more? Yes? Okay, cool. Now, but the point is that if we can always do this, why are we even learning lazy? Why are we even learning the double check locking, right? Like we can always do this, no? Why are we investing so much time in learning double check locking? We are doing that because that is called what? That is called lazy initialization. Lazy initialization. What does lazy initialization mean? That I am going to create the object only when I need it. Okay, it is possible. Okay, it is possible that I do not need configuration for most of my project. I might need somewhere, maybe later. I do not need it right now. Why should I create the configuration instance from the starting and keep it? I am unnecessarily creating that instance and keeping it. Correct? So that is why we write the double check locking wala code, this code, and we make sure that it is thread safe. We might be having multiple threads, but what are we doing? We are creating that one object only when we need it. Yes? Guys, yes or no? Yagni, yes, you aren't gonna need it. Here, we are going to create it only when we need it. So the question is that early versus early or eager, it is called, versus lazy, what is better? It depends on the case. If your case is that you are sure that you're going to use that instance very soon, or it is going to be used heavily in your system, then why do all that double check locking ka tamasha? Just do the early initialization. This is one way. And guys, this is extremely important. In a lot of interviews, your interviewer is going to ask you this: early initialization versus lazy initialization. You have to know this for even for SD1, SD2. Don't think that you are college students or something that so you don't need to know this. Don't do like this. This is a very important topic. Okay. So for lazy initialization means I am going to create it only when I need it. I'm not going to create it in the starting and keep. Early initialization means I don't want to take care of the multi-thread and all of that. I am going to create the instance when my application starts up. I'm going to create. I'm not going to take care of the multi-threading part. Make sense? Yes, no? Yes? Okay. Someone said no. What doesn't make sense, guys? Okay, no to something else. Okay, yes. Okay. When to use what? Akanksha, see, this is very, very subjective. It depends on the requirements. For example, logger is something that you're going to use everywhere, right? So I would suggest just do eager initialization. Versus say I have a food manager or order manager, and suppose it is not even suppose. Okay, let me give an example. Amazon says that I'm going to start with food chain. Okay, it starts developing it. There's a lot of food things happening, but like has created one singleton instance, one singleton class food manager. Now suppose Amazon, now when Amazon, suppose the application is huge, the code is everything together. I know it's not a very real example, but just think of it like this. Okay, so now when the application comes up, there are a lot of other things that are happening, but food manager is still not used. But very nicely, you did early initialization or eager initialization, created one static instance, and it is there. It is of no use. It's a waste. In that sense, it does make sense that you do lazy initialization, and only if you need it, you're going to create it. Right? So suppose you create any singleton objects like this, you're going to need it. Okay. Please explain with respect to language, which are single threaded. Am I getting confused? See, so the point is, see, this entire course, I started with the context of C++, Java. If you are from any other language, then this call will be the place where I'll be answering the other questions. But like when we started the course, I said that we'll be covering for C++ and Java. And we have to handle situations like this cases over there. And that is why I'm covering this. Okay. Now, guys, one very, very important point over here. Considering every single design pattern that we cover, let it be director or singleton or anything. Again, I said this earlier also, you need to understand the crux. What is the purpose? What is the main point of this particular design pattern? It is not about exactly what code are you going to write. This double check locking, it is one way of implementing singleton design pattern. Or eager initialization, lazy initialization, one particular way of writing the code. In builder design pattern, yesterday we talked about a lot of cases that in director you can have get product, you can have a getter. In builder you can have a getter, or you might not want that. Maybe you do not want a director. Your client itself can be a director. We talked about a lot of cases, right? But the crux of the design pattern was what? That there's a builder. There are like some processes, and we are directing that, okay, you have to do this, you have to do this, you have to do this. Correct? Similarly, over here, what is the crux of the design pattern? It is that we have to create one instance of the object. How you do it, in which language you do it, what syntax you use can be subjective. Just try this out on ChatGPT search. What are the ways of implementing a singleton design pattern in Java? You will find at least 7-8 ways. One way would be that you do early initialization, lazy initialization, make it thread safe, double check locking. In Java, you can put a synchronized. When you put synchronized in the function, it will become thread safe. Then see, as the languages become like as the new releases and the languages happen, the languages become smarter. With C++ 11, there has something new has come, like if it is a local static variable, you don't have to take care of multi-threading scenarios. So you have achieved the point, right? You have achieved what? That I want single instance of the object. When it comes to singleton, that is what you need to understand. And you need to know one way of writing the code. One best way is to know a double check locking. This you can always use it. Okay. Other than this, you will find a lot of ways to do it. You can use, like in C++, as I said, you can use local static variable. In Java, you can use synchronized. In C++ also, you'll find 5 other ways of implementing the singleton design pattern. Okay. The way you use it, it is going to be different. What you need to understand right now, single instance of the class. You have to make sure of that. And whenever you talk about singleton, you have to talk about multi-threading, because it is a very typical case, right? You want one instance, multi-threads gone. Yes? Make sense? Yes or no? Guys? So lazy initialization needs to be done with locking, right? Yes. So more or less, we have understood the singleton design pattern also. Let's do a quick revision of all the creational design patterns that we have done so far. Where do we use what? And let's do a quick comparison between them. Okay. So I'm going to enable you to unmute yourselves, but don't speak until I take your names. Okay. So I'm going to start taking names now. Give me 1 second. Praveena Pita. Praveena. Can you unmute yourself? Or Rajat? Or Vishesh Singh, can one of you quickly unmute yourself? Hello. Okay. Akanksha, Achal, can anyone unmute yourself? One person. Okay, cool. I quickly want one of you to tell me what is factory design pattern, what problem does it solve? Any one of you, come on, Chevanti, Chintamani, anyone. Just unmute yourself and tell me. Yes, people have started leaving, guys. It's okay. Rekha, Rohan, Rohit Kumar. Hey, factory, you should be able
Hi,
to.
Kruti.
Hi, yes, please tell me.
Okay, so factory design is one of the creation pattern, where we'll be separating the logic of creating object into the factory class.
Yes.
Let's say, yeah, we'll be creating a object for the similar type of
Hmm.
classes.
Mm-hmm.
Let's say we'll have one interface or some base class which will extend our subclass will extend it, and then yes, so it will use like say if at all it has a different uh, implementations will implement it in the subclass, and what are we going to call that will be segregating in a factory
Correct.
class.
Very good. Very good. Thank you so much. Thank you for that. Also, we create similar objects over here, right?
Yeah,
So,
right.
and also we are hiding the complexity from the client. So these are very important points, right? So whenever you think of it, just remember these, that similar objects, we have to hide the complexity of creation from the client, and we are encapsulating the creation process. Yes?
Okay.
Very good. Thank you. Now, who will tell me factory method? Who will tell me factory method? Guys, forgotten kya? Yeah, Samya, tell me.
Hi. So in the factory method, it's basically when we want to delegate the object creation process to the subclasses, and we just add one more level to that simple factory method, because now we have a creator class, which is basically declares the factory method, and it's returning that common interface of base class now. And it's actually support basically the because we moved from simple factory to factory method because it's some way violating the OCP. So that's why we moved to it. And now when we implement factory method, it supports extensibility, because addition of new objects is without modification of the code.
Yes, exactly. Very good, Samya. Thank you so much. And thank you for creating the UMS. Thank you for taking the homework seriously. Great job. Okay. Who is going to tell me abstract factory? Vikrant, Vasant, Varun, Tushar,
Hello,
anyone?
Kriti.
Hi, tell me.
Yeah. So abstract factory is when, let's say, we have a family of product. So let's say we are creating similar types of things, but for two different families, and we want one particular like main, you can say, which is going to instruct the other two to create all the similar type of products. Then in that particular method, in that particular scenario, we use abstract factory.
Yes, very good. Thank you. Okay. What next one did we learn after factory method abstract? What did we do next?
Builder design pattern.
Yes. Who is going to tell me builder, guys?
So basically builder we are using when creation process is similar, but it is complex.
Yes. What else?
There are a lot of steps in the creation process.
Yes. What else?
So configuration is different for different products.
So the way maybe some of the methods are optional for creating.
Methods are okay. Guys,
the business might be different.
Constructors.
This point I want to cover once more, and we'll talk about this. Let's quickly cover the other two also, then we'll cover this once more.
Avoid telescoping.
Avoid telescoping. What is telescoping? Having too many constructors, right? So
Yes.
too many constructors. Yeah. Who will tell me prototype?
So this pattern is used when it's easier to copy an existing instance of a object rather than creating a new one. For example, you have a very complex object like car. So no company creates a new car by scratch. They take a prototype and then they modify it enough to basically create a new car. So in that way, making a car prototype instance would make sense.
Right. Thank you.
And the cloning is also done by the object itself.
Yes, the cloning is, you're delegating the cloning process also to the object. Thank you.
Yeah, one quick question. The cloning will be deep or shallow, or could be either of them?
So if it is shallow, then what is going to happen? Or what if it is deep, what is going to happen? Did you try the quiz yesterday?
Shared.
Did you try out the quiz yesterday? It was
Yeah.
Yeah.
Yeah, so it will be shared amongst different objects, which is also okay in sometimes, right?
But when you're cloning, you are essentially trying to do what? Like trying to do what?
Okay, yeah. No, I got confused with flyweight, so it's okay. Yeah.
Kirti, yesterday did we discuss what is shared statement? Like there was a quiz in that which you asked.
No, not yet.
We will discuss that, right?
Yeah.
What is shared state? Like you have asked for shallow and that, and then shallow doesn't share the state. Something like that was a quiz. So
we'll discuss that in detail. Yes. Okay. Singleton.
When we want only one instance of an object, we'll use singleton. Here we'll make the constructor private so that the client couldn't create many instances.
Yes, very good.
And we'll have a get method, which is actually checking for the instance, and if it's already available, it will give that. If not, it will create and give.
Very good.
And when there are multiple threads, we'll use a locking so that it is thread safe.
Yep, very good. Double check.
Kirti, I asked just one question. Static class inherently is singleton, is it? If I make a class static, will that also be considered to be I'm following singleton, I'm making a singleton?
If your class is static, will it be singleton? Are you from Java or C++ background?
I am from nowhere. I don't know either of them. I don't know either of them. I am just trying to understand the conceptually. So Java, mainly Java, towards Java.
Okay. Java people who's going to tell me if I just create the class as static, does that mean that the class is singleton?
Ma'am, I think in my knowledge, only inner classes can be made static. Top level classes can't be static in Java.
Okay. Yes or no? Whoever is saying no, why no? Modi ji is saying no. Modi ji, why?
Can't even create objects, right? If we make the classes abstract.
If we make the classes?
If we make classes static, then we will not be able to even create an object of that class.
And we want to use the object of the class. Okay.
Right.
Okay. So if you have the object of the class, you want to work on that and you want to call the functions from there, right? That is one good point. Yes. Static classes are used to declare constants. Okay. Any other point that anyone would like to add? So if I say that I'm just going to make my class as static and use that as my singleton class. Can I do that? Yes or no?
I don't think so.
Yes, we can't make it as static. Only inner classes could be static.
Okay. What about C++ people? What do you say?
No, you cannot make static class in C++.
Exactly. So that is why we need to know singleton. Yes. Cool. Okay. So guys, you guys have understood the different creational design patterns. What are the different scenarios in which we need them, right? So whenever we talk about creational, we have to think about this, that are we just, do we want to encapsulate the creation process and keep it like different factory? Do you want to delegate the creation to subclasses, further improve the factory to factory method? The factory means, when I say factory, I mean simple factory. Okay. When I have to create a family of families, I'm a family of similar products, abstract factory. Builder, process is there. Prototype, copy or cloning, right? Singleton, one single instance. Now, at least for creational, are you guys clear? Like, when are we going to use what? We're going to look at a lot of code and we're going to see a lot of examples and all of this. But now, whenever you see creational, you should be able to identify, yeah, this creational design pattern will make sense over here. Okay. One point that I wanted to cover about builder. Okay. Let's see, builder, when we covered yesterday. Over here. So when we covered builder, we saw at the chaining method also. Do you remember that it could have been done like build build floor dot build ceiling dot build kitchen dot build windows. Remember, we looked at the code. Do you guys remember that? Yes or no? Remember doing that chaining method? So what we did something like this, that builder dot build something dot build something more dot build something else dot like this, right? So sometimes in order to make this chain look better, what will we do? Instead of this build, we'll call with, like we'll call the function like that. So the chain will look something like this, that builder with say, or you will call the function as build, right? So the function will be like build, and then you are going to say that dot with floor dot with say ceiling dot with something else, right? Like this. So when we say that we are we can configure this. So sometimes when say the desktop one, I say that build dot with RAM, with processor, with SD card, with graphics card, like that. Okay. Now suppose while creating a laptop, my director decides that I don't want to add any graphics card. What I would have to do is just delete one with part. Like just don't call this one part, right? Don't do this dot and call this method, correct? So now when we say in builder that it is configurable, we mean that in the chaining part, you can do dot, 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 and you can choose to not include a particular method. You can choose to do that. But remember, you should not force any builder to implement a method that it doesn't need. Let me give you an example. So the desktop example that we saw, the Dell desktop, HP desktop, Sony desktop. Now you decide that, you know what, I want to create one for all electronics, not just for desktop. But instead of doing so much effort, let's just have one more over here, and I'm going to call it for say iPad builder. Okay. Now iPad builder doesn't need the keyboard and the mouse, no? So don't simply have like iPad builder and have like a build keyboard and have empty function. That is violating which principle? Which principle are we violating? ISP. Yes. So we do not want to force any builder to have a build method that it doesn't need. We should not forget that. But how you can make it configurable? That in the chaining method, or your director can say that, okay, for this particular type, I do not want to add this particular method. But it is not like you're going to force a particular builder to add a method. Make sense? Yes or no? Yes? Okay. So now, congratulations. We are finally done with creational design patterns. So there are 3 types of design patterns. One was creation. What are the other 2?
Structural and behavioral.
Yes.
Titi, one thing I just wanted to ask.
Mm-hmm.
The situation which you just explained, where we need to create an iPad monitor. In such scenarios, what is the ideal way? Should we go and create another builder from where we will derive our similar iPads? Is this the ideal way?
See, if you have to create, say, iPads and laptops like that, I would say that it could also be family of similar products, right? And we can also probably compare something like combine builder and abstract factory or something like that. I want you to start thinking about this. Why abstract factory? Because iPad, like family of similar products, right? iPad and desktop. Why builder? Because similar processes. So I'm just making you think what would be the possible solution if you have to do this. Just think about it and try to convert it into code also, right? You understand why am I suggesting abstract factory? Because a family of products.
Correct. But in that case, if there is any product,
like we do not want to force builder. When we use builder, when we know that we are going to have these processes, right? But now if we are not just creating desktops, if we are creating iPads also, if suppose we are creating mobiles also, other electronics also, it doesn't make sense to have those build processes. Probably some other build process would have made sense. Okay, I can see a lot of people are confused. Let me
Correct.
repeat.
So usually what happens, Kirti, is like in such scenarios, we face it during our regular work also. So it may happen that in one of our in one of our interfaces we have three methods which are common, and I may come up a situation similar to iPad where three of my methods are same, but one is different or two is different. Then in that case, if I'm implementing that interface, how will I be able to call methods which are specific to my object, right?
See, that is why like the entire concept of low-level system design comes, that we have to make sure that our code is extensible, maintainable. When we have converted our UML into, when we have actually started coding, we should see the correct way. The correct answer would be that we should have foreseen this. We should have made our code as extensible, maintainable, right? That is the whole point of like using it like this. But if you are not able to do that, like, you know, if you had a builder and now you have to have like an iPad, I would like how I would handle the situation is I would not still violate solid principles. I would not violate ISP. I would never suggest to have a method that has no, nothing inside it happening, just like a dummy method over there. I would never suggest that. Like maybe create an outer level, say factory or abstract factory or find some other way to deal with the situation, but never force like a simple dummy method.
Correct. So you will basically come up with a new interface, right? That has your own specific methods where you may need not to unnecessarily override those methods, which is not doing anything, right? So the ideal approach would be to come up with a new interface or an abstract class that has specific methods that belongs to your object, that makes sense for your object, right?
Exactly.
Okay.
For those who were confused, let me repeat that. So yesterday we did this example of desktop builder, right? We said build RAM, build processor, build speaker. There was also build keyboard, build monitor, right? So now my point was that suppose tomorrow, right now I am building only Dell, HP, Sony desktop builders. Tomorrow, if my manager comes to me very nicely says, Kirti, just add iPad builder also. No, now we want to create iPad also. Okay. But don't do that, please. So what is going to happen is that I am going to create another iPad builder over here. So this one. So now what happens is that I have some functions, say build keyboard, build mouse, build this, right? And my iPad doesn't like, it doesn't make sense to have build keyboard or build mouse for iPad builder, correct? So what you're going to do is build keyboard for my iPad builder, and like if we have to force fit, we are going to create a dummy method and do nothing inside it, which is not the correct way, which is exactly what we are trying to solve. Yes? Okay. Guys, can we move ahead now?
Yes, Kirti, one more thing. The thing in context of Python, the singleton defined pattern, actually Python has one global interpreter locker by default, which avoids like multi-threading. So
Okay.
I'm little bit confused how the singleton will act in that case.
Okay. Can I please pick this up over Discord? Please.
Sure. I will. Yeah,
Please
I will
message me on
take the
Discord.
question.
I will
Sure.
definitely pick it up. Okay.
Sure.
Kirti, can you please explain the prototype shallow copy and deep copy example?
Can we do this later now, because it is 10 p.m. and we need to cover 2 more design patterns today, right? So I will pick up more questions, but now I will have to regulate the class. Sometimes I have to do it. I have to be a bad person. So don't feel bad, guys. I will pick up more questions, but I have muted you all again. And can we all please now, for now, forget creational design pattern? I'm really sorry for this, but I have to, because we have to cover the course also, right? So we are starting with behavioral design patterns, guys. Congratulations, everyone. Pat on the back. It is 10 p.m. Hope you had a good break, 5 minutes discussion. Can we get started with behavioral design pattern? Yes, no, excited, doesn't make sense, make sense. Yes. Can I get yes, more yes? Until I get like good number of yeses, I'm not going to. Yes, that was a break. Yep. Okay, cool. Okay. Give me 1 second. Let's start with an example. What are we trying to solve? How are we going to solve it? Okay. So today we are designing a weather app. Okay, so there is a station where I am checking that how is the weather right now, and I want to display it. Okay, so I want to display multiple things. Like I would want to have like a digital display. I would probably want an analog display, maybe a graphical display when I show that actually rain is happening, right? Different kinds of displays, right? So now the point is that whenever my station gets the news that, okay, the weather has changed, as checks that, okay, the weather has changed, every time some change in the state happens, right? Every time a change in the state happens, a behavior change happens, what am I going to do? I'm going to make sure that the display is changed correspondingly. As soon as it starts raining, my display should change. As soon as it is sunny, my display should change. Does it make sense? So my weather station is going to detect the change in, say, temperature, humidity, weather in general, and is going to display accordingly. Multiple places we have to do that. Similarly, let's take another example. Suppose traffic light system. Okay. Traffic light system. Now I have this red green wala thing, right? Red green light. Now suppose there are different lights for, say, vehicles and different one for, say, pedestrians. And say, like, there are different lights. So there are green, red. So every time a state changes, what's going to happen is that either green vehicle light needs to be changed, red vehicle light needs to change its state. Like suppose if the green one was off, then it needs to turn on, and maybe red needs to turn off. Maybe pedestrian, like if the green light was on, then it needs to turn off, and the pedestrian red one needs to turn on. Does it make sense? That every time I make a change, like there is some timer that is running. As soon as suppose at this 60 seconds is over, that okay, you have been waiting for 60 seconds. Now red will turn to green. Okay, so red will turn to green. So suppose red vehicle right was on. So now it will turn off. Pedestrians green was on. Now it will turn off. Yes? Make sense? So now suppose 4 lights need to be told that you need to change your state or you need to take some action. Right? You need to take some action. You need to update yourself. Does it make sense? Yes, no? Hello. Yep. Similarly, say another example, alarm system. Okay, there's an alarm system and home detection, like home automation and all of that. As soon as we detect that, okay, some intrusion happened, suppose we are going to do multiple things, right? We are going to suppose notify the owner, or we are going to trigger some alarm, and we are suppose going to turn on some extra cameras that, okay, let's see what's happening, or maybe call police. Yes, exactly. Emergency number. Right? So we need to take care of multiple things. Now, as most of you have already guessed, this is observer design pattern. Why is it observer design pattern? Basically, there is a subject. There is a subject whose state is going to change. And then there are observers. There are observers who are observing that as soon as a change in the state happens, I'm going to make the change. I'm going to take an action accordingly. I'm going to update myself. I'm going to take some action based on the change in the subject. So there is one subject, there are many observers. So note over here, this is one-to-many dependency. Basically, there is one subject, there are many observers. Make sense? Now, I know for those of you who know high-level system design, for those of you who don't know, just ignore my next 2-3 lines. For those who know, some of you are going to get confused with pub-sub pattern, publisher-subscriber pattern, right? And it is essentially the same thing. There were publisher, there were subscribers, and there were publishers, and people were subscribing. It's essentially the same thing. But try to view it like this. In lower-level system design, when we talk about observer system design, and when we talk about observer design pattern, we're talking about classes. And try to view it as like a smaller system, as a compact system. like weather app. That's why I gave you these examples, weather app, traffic light, alarm system. But when you look at the examples online, you will also see notification system. Like suppose if I have to take an example of Swiggy, Zomato, say there's a change in the state of, say, order, Swiggy order, or Uber order, or say Ola, like whatever, Amazon order, right? So when there's a change in, say, this order, who all need to be notified? In Swiggy order, suppose who needs to be notified? My delivery partner needs to be notified. My customer needs to be notified. My restaurant needs to be notified. Uber order Uber ride ka status changes. My rider needs to be notified. My driver needs to be notified. And suppose my system or some other notification needs to be triggered. Amazon also, multiple people will need to be notified, right? So yes, in HLD, you will look at it in microservices level. And if you don't know HLD, it is fine. For those who know, I'm just creating like a comparison. In low level system design, when we are talking about class level, you need to think of it as a compact thing, that, okay, there is one class, there's a state change happening in one particular class, and there are other classes that are that have observed or subscribed to this change, that as soon as the change happens in this particular state, I need to update, I need to do something. A change happened in the weather, I need to display it accordingly. A change happened in the traffic light. Okay, 60 seconds are over. The timer change has happened. I need to take some action accordingly. Yes, makes sense. Similarly, you will see one a very common example like cricket score. So when you have to show in many places, so suppose whenever there's a change in, say, a wicket happened or a run was taken, a lot of things are happening, right? So there is one place we are maintaining the score. Now we are displaying the score in multiple ways. Like suppose we are showing it in like these many, these many runs to win, or this is the final score. Suppose we have a digital display, and suppose we are doing some calculations also. Suppose we are doing average run rate, or some calculations we are doing. I don't know the technical terms, but some average calculations we are doing in cricket, right? So you do understand the point that the change is happening in one place and we are looking at multiple places. Make sense? Yes? Can I get yeses? Do you understand the problem that we are trying to solve? Okay. Let's look at the UML, how it is going to look. Okay. So everyone understood that it is one-to-many dependency. State changes in one place, which is the subject. Observers need to make some change, need to update, or need to do something. Okay. So let's try to make the UML diagram now. So say there is a subject. There is a subject, correct? This is where the change is happening. Change in the state is happening, right? So basically in the weather one, this is the subject. This is the subject. This is the subject. Like whenever, whatever is the trigger that, okay, this happened, now you need to make some change. Now there's a one-to-many relationship, right? So there are many observers. And they need to take some action when the state changes. So obviously there has to be one function over here and it has to be public, right? So plus sign, and it has to be like, something like say update or say notify, like one of this, like usually you will say update or notify, like the function name. Let's write both. This much makes sense. So observer has to have this one function update. Subject has to notify all the observers that, okay, you have to get notified, right? Yes, everyone understood this much? Yes, guys, yes, no, yes, no. Yep. Okay, great. Now the thing is that this subject should know that which all observers do I need to tell that, the change has happened. Like for example, traffic light has these lights. Now suppose one new type of light comes. Suppose I have this banner that displays that now you can go, you have to stop. Suppose a stop light comes up. Now there's a new kind of light. There's a new observer that has come. So I should be able to add the observer, and also I should be able to remove the observer. If I decide that I do not want the pedestrian light anymore, it doesn't make sense because no one even follows it, right? Yes, so we should be able to follow OCP. Open close principle means what? Our code should be extendable without making any change in the previous code. Correct? Yes? Yes? So you understand the fact that I should be able to add observers and remove observers. And I should be able to do it seamlessly. So my subject should know that these are the observers who need to update or notify. So for that, what are we going to do is, we are going to have an observer collection inside this. Observer collection. Now, this observer collection means a list of observers. You can think of it like this. How you use it, again, the crux is that you have to have like a collection. Now you can do it using vectors in C++, you can do it using array list, you can do it using an unordered map, a map, anything. Doesn't matter. The point is there should be a collection. Everyone with me so far, yes or no? Guys, this is also a very important design pattern, by the way. So you have to like understand this properly. After factory and Singleton, this is probably the most important design pattern. It is very common also, so you need to understand it. Okay. First thing that we understood, that there is a subject. There are observers who are observing the change that is happening in subject. Okay. So subject needs to have something that, okay, these are the observers who are observing me. Correct? So obviously I should be able to attach the observers, detach the observers, right? So basically I should be able to do what? I should be able to register observer. Okay. And I will obviously pass observer inside this. And I should be able to unregister the observer. This essentially means what? That from this collection, I should be able to add new unregistered, deregister. Okay, you understood? No, attach, detach, whatever. Understood? That you should be able to add to the collection, remove from the collection. Make sense, everyone? Yes, yes, no, no. Make sense so far? Subject has a collection, we should be able to attach, we should be able to remove. Yes? Now, obviously, we need to call this method sometime, right? So every time a change in the state is going to happen, what am I going to do? I am going to notify the observers. Make sense? Yes or no? So these three functions need to remember. This UML is extremely important. You need to understand it very, very properly. There is a subject, there is an observer collection. Because there is a collection, you can add the observer, you can remove the observer, you can notify the observers. Simple, right? As you can see, subject has a collection of observers. What relationship is it? What relationship is it? Subject has collection of observers. What relationship? And obviously observers should be able to, okay, now some people are saying aggregation, some people are saying composition. Everyone has understood it has a relationship, right? But usually, obviously, it does make sense that my display should be able to exist without the weather app, without the subject, or, notifying or the trigger or calling or turning on, all of that should be able to exist without the subject, right? That is why it will be aggregation. Understood? Subject has observers. Observers can exist without subject. So that is why this. Yes? Okay. Can I please repeat it? Yes, I'm going to repeat it. There is one to many dependency. One is what? It is subject. Many is what? It is observers. These observers can exist without subject. The life cycle of the observer does not depend on the subject. First class or second class. Remember it? Remember, composition aggregation has a relationship. Observer collection is there in the subject. Yes? We will look at the examples, don't worry. How will the notify observers look? Let's quickly look at that also. This notify observers will look something like this, like the function. We will go like for every observer in the observer collection. What you're supposed to do, you're supposed to call observer.update or .notify. Make sense? This is how it is going to look, like a loop that we are going to call update for every observer. What is the difference between notify observers in subject and update notify an observer? Okay, now you have understood, no? That I will show you the code also, so it will get clearer. Basically, my subject has this for loop. And from here, I am triggering this function. It's a list of observers, right? So for every observer, someone has to call this, no? So when the state change is going to happen in the subject, we are going to call this notify. I'm going to show you the code, don't worry. And obviously, the observers are what? They're similar objects, like this display. These are displays, right? So if suppose displays were observers, it would be something like this, right? So there's a display. There will be analog display. There will be digital display. There will be graphical display, correct? So this is one observer. Obviously, there are going to be what? Concrete observers. Concrete observers. And this will become an abstract method. Why abstract method? So concrete observer say 1. This will be concrete observer 2. Why abstract? Because all my observers should have this notify. Why should they have notify or update? Why should they have update? Because I'm going to call that from subject. No, otherwise I'm calling from subject. It is not there only in concrete observer. How will I call? Make sense? So it means that every time a change happens in the subject, all of my concrete observers need to call this update. Yes? Okay. Can we use interface? Yes. This is your observer can become an interface or an abstract class. Yep. Okay. Now let's. Okay. I was reading chat and I forgot what I was about to say. But okay, cool. Never mind. Let's look at the code. Can we look at the code? Yes. Can we look at the code? Understood the need of it. Why are we using it? What are we doing? Let's look at the code and then I'll answer more questions. Yep. Okay. Can you all see my screen? Can you all see my screen? Okay, let's go to observer design pattern. Let's look at the C++ code. I have written the order status wala example. So there is an observer, correct? There is an observer. This is basically the interface. You were talking about making it interface or abstract class, right? So you can see update is there. And this is virtual void means, this is pure virtual function means what? That all the concrete observers have to have this update. Let's see the Java code also. So in the observer, there is one update and this is an interface. Make sense? Yes? Looking at the chat. I'm confused about concrete observers. How will it change anything? Okay, let me tell you. So observer is there. Then these are the people who are the concrete observers. Basically, we took the Swiggy, Zomato example, no? That whenever a change happens in the Swiggy order, who all need to be notified? The customer needs to be notified. The restaurant needs to be notified. The delivery driver needs to be notified. And suppose call center also needs to be notified. So all the 4 people need to be notified every time a change happens in the status of the order. Make sense? The scenario makes sense that what are we coding for? Yes, no? So this is the observer and these are the concrete observers. So customer. Now see, when customer needs to be notified, I will do something. I will take some action. I will send the notification to say the customer. So this is the point of concrete observers. What is the point of concrete observers? That it is the one that is actually doing the action. Like in a traffic light, it was the one that was actually changing the light or say changing the behavior, if you think about it. So that is why behavioral design pattern. We are changing the behavior based on the state change, right? You remember traffic light, we were making it on, off, red light, green light, or digital. We were changing the behavior of that. So basically we are changing the concrete observer. Customer is a concrete observer. Restaurant is a concrete observer. Delivery driver is a concrete observer. Call center is a concrete observer. Does it make sense? Observer and concrete observers make sense? Yes? What is the use of constructor? Nothing here. I just wrote it to give you some name. Okay? Okay. Order is there. Order has some ID again to give you some feel. It is not like it should be there. This is your observer collection. Here I've made it using array list. In C++, I think I've done it using vector. Yes, so you can see vector of observers. The point is it has to be collection in any form. Keep a map, keep a vector, keep a array list, you keep whatever the hell you want. It should be a collection of observers. Make sense? Yes? Okay. Now order, as the constructor is there, getter, setter, all of that is there. Look at this. Whenever the status change happens, I am going to notify all the observers. What are the three very important functions? These three. These are the three important functions that you need to remember. Look at them properly. Attach, detach, notify observers. Attach means what? I am adding to the observers list. Detach means what? I am removing from the observers collection. Notify means what? Just for every, I just wrote this, right? For loop, for every observer that is there in the collection, update. This is the one that is going to call the concrete observer. Like here, what is there in the collection? The collection, there is customer, there is delivery driver, there is restaurant. All of them will be updated. Let's run this and see. Let's run the code and see. I guess it will be clearer then. Let's run both the C++ and the Java code. Okay. I'm in Singleton. So I'm going to go to which design pattern are we doing? Observer design pattern. Java. Okay, this is too big for me. This is order status, right? So this status.java and let's run it. So here you can see in the main what was happening. Okay, let's look at the main. So in the main, I first created an order, right? So I created an order. And after that, what I did, I just created some observers. Customer, restaurant, driver, call center. Okay. After that, for that order, I attached. So this is where I'm attaching the observers. Attach customer 1, restaurant 1, driver 1, call center. And I said out for delivery. When it was out for delivery, let me just see out. Oh, sorry. This is Java. Oh my God. Okay. System. I'm going to see. This is out for delivery. Okay, let's run this once more. It will be clearer. See, so this is the starting. This is how much. So when I check the status to out for delivery, who all were notified? All the 4. Customer 1, restaurant 1, driver, and the call center. All 4 got what? Notification out for delivery. After that, I nicely detach the call center. I am not going to tell the call center. So when now I change the status to delivered, only these 3 were told and the call center was not told. See, on the fly, I can attach and detach the observers without making any change. No change I had to do in the observer, in the subject, like no change I had to do. Easy, right? Yes? Make sense? Let's run the C++ code also. Otherwise, C++ people will feel bad. Let's look at the code once. So this is the order. This is observer. So basically, this is pure virtual because it is interface. Okay. Concrete observer, customer. It has an update. See, this update is pure virtual, right? So all the concrete observers have to have update. I have written all the functions together over here. You can see customer update, restaurant update, delivery driver update, call center update. All of them have to update, right? So here I have updated in customer, in restaurant, in delivery driver, and in call center. All of them should have an update, right? Now after that, in subject, what is there? There's a vector of observers. And here, these are the 3 functions that we should know. These 3 functions. These are the 3 functions. Attach, detach, notify observers. Attach means we are adding to the observer. Detach, we are finding the observer and removing it. Notify the observers. Here, we are calling the concrete observers ka update. Right? Let's run this also. So again, I've done the same thing. Order is 1, 2, 3. 4 things I have like initialized: customer 1, restaurant 1, delivery driver 1, call center 1. I attach all of them. I set the status. Then All of them should get this, that out for delivery. Now what am I going to do? I'm going to do a big this so that it is properly clear. Okay. And so every time I change the status, let me just do this right over here. Over here. Good. Let's see this. Let's run it. So what is the name? So here you can see that earlier all the 4 were notified out for delivery, then only 3 were notified because I nicely detached the call center. Make sense? Yes? Okay, cool. I am going to stop sharing now. Understood observer design pattern properly? What type is it? Is it structural or behavioral? Is it structural or behavioral? Structural, behavioral, behavioral. Why behavioral? Why behavioral? State changes, so behavior. So basically, when do we use behavioral design pattern? When do we use behavioral design pattern? So today and tomorrow we are going to be discussing behavioral design pattern. So you should know. See, basically when the objects and the classes interact and communicate, like, you know, the way they are talking, the behavior is changing. We are going to focus main on the flexibility and the maintainability. It is going to be behavioral design pattern. Don't talk about structure right now. Don't ask me the question. When we come to structural, we will discuss them. Okay. I am allowing you to unmute yourself. I will take questions for 2 to 3 minutes. Any questions related to observer design pattern?
Kirti, subject is not violating OCP. Like I need to add that, attach. I need to call that only, na. Like we had a director in builder pattern. Now here we have just a subject and that is a subject and there are observers.
But you are not making change in the subject, right? You're doing it from outside. So suppose my client, wherever my main was, you could see over there, right? So it was doing wherever the subject was, I was attaching from there. There is no change happening in the subject. I am attaching and removing from the subject, but is there any change happening in subject?
So that we have written in the client, attach and all these functions we are called in a client.
We are calling from the client, like whenever we want to attach, like the client can do or whoever else can do. But like when you want to, but there's no change happening in the subject, no? It is happening seamlessly from the collection.
Achha, and one more thing, like SRP part. Subject is like changing its state. It might be doing other things, right? It might have other functions rather than.
No. So we have to follow solid, right? Let's talk about solid over here. How are we following SRP? Let's talk about this one by one. Subject is only responsible that, okay, when the state changes, I'm going to notify the observers. It is only going to take care of this. Okay, if you're following SRP, how the state is changing, whatever is happening should be happening somewhere else. This subject should be responsible only for this.
So for order, I will have a subject would be order observer, order subject.
Good question. So usually what will happen? So to demo, I called it order, but obviously order will have a lot of details and all of this. So there will be like order status tracker or order status updater, something like that. The function will be called, the class will be called that, and that will be the subject.
Okay, then fine. Yeah, okay.
Obviously order will not, because order, like it is supposed to have a lot of information. It is supposed to do so many things, right?
Okay, thank you.
Let's quickly cover how we are following solid. SRP we talked. OCP, how are we following? I guess most of you have already know this. We can add the concrete observers. We can remove the concrete observers on the fly. So it is extendable. We won't have to modify the present code, right? How are we following LSP over here? What does LSP say? That everywhere I am using observer, I should be able to use these concrete observers. So I'm following LSP. Yes? Guys, awake? People are sleeping. I can hear the karate till here. Can I get yeses? Okay, cool. ISP. So I have small interfaces, correct? So it is not like I am forcing anyone to implement something that they don't need. Everyone is supposed to have a concrete observer. Everyone is supposed to have an update or notify. Yes. So I'm not forcing anyone to do anything. Dependency inversion, how? So this is an interface. So this is my high level module. These are my low level modules. This is depending on what observer on interface. So there is loose coupling. This is very important point of observer design pattern, that there is loose coupling. Yes. So if we have to talk about main things, one thing that you have to remember is one-to-many dependency. Second thing that you have to remember is loose coupling between the subject and the observers, because see, subject doesn't know which is the exact observer. Subject has no idea who are the concrete observers. Correct? Subject just knows that I have observer type. So how was the collection looking? It was like this, no? Vector or say list. So it was say like a list of observers, or you can call it I observer. It has no idea of who the concrete observer is. So there is loose coupling between the subject and the observers, right? And when the state is changing in one object, all of its dependents or observers are notified and updated automatically. We don't have to make any change. Yes, makes sense? Everyone is understanding observer design pattern. Everyone is understanding why behavioral design pattern. Any questions? Can I move ahead?
Yes, so Kirti, one question. So state change is nothing but addition of observer and deletion of observer. Is that correct?
No. State change is not that. State changes, weather has changed. It has started raining, or 60 seconds have completed. Now state has changed. Now you need to take some action. Or the order status has updated. The state has changed. The like intrusion has happened. The state has changed. Like I'm saying, some change happened in the subject. Like, so suppose it started raining or it became sunny, some sensor data, right? Right, exactly. So we are seeing whatever change happened in the subject, we have to update or notify the observers accordingly. Subject's data.
Basically, properties of a class.
Yes.
Okay, so properties of class. So can you explain it again how it is implemented in code? Like as far I understood, it's addition and like how it translates into code, like state.
How it translates into code. So did you understand that order status was there in the Swiggy code that we saw?
Yes, understood. Yeah.
Right. So now see, how is the state changing? We're not talking about that. Someone is changing the order status. Like suppose it is out for delivery. Who is going to change the status? Suppose restaurant is going to change the status. Who is triggering it is not the important point over here. There is some state change that was triggered by someone, by some class, and now some observers need to be notified. Is that the confusion, that who is triggering it? Who is
Yes,
triggering?
exactly. Yes.
So that
Yes.
that when we actually start implementing observer design pattern, for now, just think that there's some state change that happened. How it happened, we'll talk about that. How the order status change happened, like in Swiggy or Zomato. Obviously, like if it is out for delivery, restaurant is going to change. And if it is delivered, our delivery driver is going to change. If the payment is done, our payment gateway is probably going to change. Customer has placed the order, customer is doing it. How it is getting triggered, we are going to discuss later. For now, the point is, once some state changes, once the trigger has happened, observers need to be notified. That is the point that we are focusing on right now. Makes sense?
So, Kirti, can we say that we need to do the attachment only once, and every time we are changing the status, we have to like detach any one of them, the observers?
Why would we have to detach? Only when we want to stop notifying them. See, once we have attached,
It's not necessary.
Right.
once we have attached, all of them will keep getting notified. But when we don't want anyone to get notified, suppose as a customer, I say that I don't want the notifications. You just give me the order. I don't want the notifications that it is starting to get prepared. It is out for delivery. Don't send me the notifications. I click there. I do not want to be notified. Then you are just going to remove me from the observer collection.
Okay.
Kirti, even the observer can have a subject, and it can use that subject to tell that, okay, I don't want to get notified. Is that relation possible? Like each observer has a reference of subject, and it itself can use to like register itself or deregister itself.
How will you do it? Subject has observer, observer has subject.
Correct.
How?
So
Correct.
suppose.
How will you do it?
So suppose I'm creating an object of observer, and in that constructor I can pass the subject, right? And that subject, and using that subject I can deregister myself whenever I myself require, right? I don't want client to deregister myself. Suppose I am done with my subscriptions. I'm considering from the point of view of subscription, right? Subscription and say newspaper subscription, and suppose after 1 month I don't want that subscription, I will myself go and tell that okay, I will trigger that unregister using the subject. Can I do that?
Okay. So the question is that the observer itself should be able to trigger the unregister part.
Correct. Correct.
Okay.
Whenever that observer wants.
Okay.
But anyway, that should be a part from the observer only. Na? I should be able to register and deregister. Observer should be able to
But
do
how
that.
how it will do it without subject?
Yeah, it should have a subject.
So that's what my question was.
See, we are passing observer over here that you need to unregister this. But the function is inside subject. How will the observer call this unregister observer?
Currently, with this situation, it cannot. But if I want to make it happen, that each observer should have the subject also, right?
See, I don't think that is the correct way to go about it. The correct way would have been that there is trigger somewhere outside. That the trigger is outside, and we are saying that unregister this particular observer. Like, because if subject has observer, observer has subject, then there is cyclic dependency, right?
So here the third party is involved that will decide, okay, I will deregister this observer, right?
Yes.
No, it's like Kirti, it should not be like subject should be able to register and deregister. It should be other way. Like I should be able to register or unregister myself.
You're correct. But the function is in the subject, right? See,
Function is
we
in the
do not
subject.
want to make it tightly coupled, and we don't want that observer has subject, right? Observer should not have subject. Subject has a list of observers.
Yeah, correct. Subject has list of observer, but this function should be able to call means observers should be able to call register observer from itself. Like observers should be able to call it.
Okay, tell
Subject
me
का
how will
function.
it look in the code? Like, how will it look in the code? So there's an observer, there is update. How will it call subject and register observer?
Think of it like suppose register observer is a function. Suppose it is a static function. So I should be able to call subject : register observer and pass this. If I pass this, it will like register. It will put this object into the list.
So you're
Static
making it.
methods. Static methods cannot access instance variables first of all, and in this case, it can be achieved if you have a setter method which accepts a subject. You can you can store the instance variable of the subject, but it's not an ideal way to implement
Correct.
such things.
See, if you have to do it, you can, but then ideally, see, subject has observers, and it should like observer should not know who is the subject. It should just know that okay, I need to update myself. If it wants to deregister, maybe wherever it was getting registered, like wherever the trigger is happening, there only we have to unregister. It is possible but that is not the correct way to go about it.
Yes, I think this is a nice question, because in the email case, if an email we are getting from some website and we want to subscribe and unsubscribe that notification from our side. So is that possible that this design method could be applied in that case?
Obviously, it has to be applied in that case. But see, who is unregistering is the point over here. According to me, it should not be an observer. Like for now, I can check it again and I'll let you know if that is the correct way or not. According to me, observer should not have the subject. The trigger should happen outside. Even if in the mail we are saying we are unregistering, the trigger should happen outside that, okay, this is the observer or this is the particular customer, right? And you're going to tell the subject, whoever is notifying, say suppose we have notified to a magazine, right? There's a magazine. And then who are the observers? They say customer 1, sorry, there's customer 1, customer 2, customer 3. And my customer 3 says that I want to unregister, I do not want it anymore. So what am I going to call is that I have this magazine, I'm going to say unregister, and I'm going to pass that customer 3 is the one who wants to unregister.
So in this case, what we are doing is means customer 3 is submitting the request that I want to unregister, and this magazine class is unregistering it.
Yep.
But back to the original question, what was been asked, if customer 3 only want to unregister, you do not want to call the magazine class. So basically what we are doing in the observer collection, we are maintaining the list of observers. So
see, basically the thing is, in that case, you are tightly coupling observer and subject, according to me, because your observer has the information of subject.
Can we just use a third party for just the observer, like register part or deregister part? Like the observer will request to the third party, and the third party will take care of the register and deregister. In that way, the subject also doesn't have to know who is the observer. The observer doesn't have to know who is the subject.
Exactly. See, the point is you can do that. Customer 3 goes that I want to trigger this, but is it correct is the point. We want loose coupling between the two. What was the whole point of this? That observer, like otherwise you will start keeping that customer 3, these are the subjects, or like, then it becomes like tight coupling, right?
There should be some authentication token passed, right? To like authenticate this is the user which is getting
But then like that you keep everything inside the user only, no? Then why are we doing LLD? That is my point.
Can you show the code once that what you're showing, observer?
Kirti, I have a doubt. Sometimes the observer may need subject's state, right, in order to do some actions.
Sorry. Can you repeat that?
Sometimes the observers may need the state of this subject, right, in order to do
So
some
when
actions.
when we call update, no, in the update we can have like a parameter. So in update we can have a parameter, right? So
in that case, observer will come to know about the subject, right?
So in the update, like right now we are passing the order, right? So here also you can see that I am passing the state, no, that hello customer, your order is now, and this is the state out for delivery. Correct? So we are passing in update, we are passing the order. So we are passing basically the state. So you can pass whatever needs to know. Okay, guys, quickly, 5 minutes, I'll quickly run through the code again. And I know it is 10:45, but I need to start the other design pattern also. We'll take 5 minutes, 10 minutes. I'll just introduce you to the next design pattern and we'll cover it tomorrow. Okay. I intended to finish it today, but we can't. So I will introduce it to you. Let's quickly look at the code once more for those who are confused. There's an observer. Now, these are the concrete observers, right? Now, you're saying that this customer should be able to deregister from that, right? It should be able to deregister. But customer has no information. Like, so who has information? My order. Basically, I'm calling it order. It can be like order status tracker or something like that. So my order is the one who has the collection of observers. So see, technically my observer also doesn't know who is the exact concrete observer. If it is customer, if it is delivery driver, if it is restaurant, it also doesn't know. Both are loosely coupled. Both don't know of each other. Order doesn't know who is the subject, and subject doesn't know that, okay, opposite. This is the subject, so subject doesn't know who is the concrete observer, and observer doesn't know that who is the subject. Does it make sense? Guys, everyone, whoever was confused.
Observer knows subject, right? Because we are calling subject
See,
register.
this is the observer, no? Where does it know subject? You tell me in the code.
We are calling subject dot register.
So we are calling subject or register. We are doing in the main. That subject, this is the subject, dot register. A register is attached. We are passing the observer.
Yeah. So Kirti, what if in the line 140?
The line
Let's go to line 140. Yeah.
Hmm.
So this line of code, what if we copy it and put it in our observers?
Then you're tightly coupling it.
No, I'm just telling you we can register like this, right? And pass, if whatever we are passing ampersand customer one, we can pass this.
So basically, attaching, detaching will be the
Yeah,
responsibility of.
It will become tight coupling. Yeah, I guess.
It will become tight coupling. We do not, the entire point of observer design pattern is that we want loose coupling. Why do you guys want to pass subject to data? See, possible hai. It is possible to have subject inside observer. I'm not saying it is not possible. You will find a workaround of it. But is it the ideal way to go about it? We want loose coupling. We want it to be maintainable, extendable. We do not want to know like exactly who is the subject. Our subject, let the subject know. Once we have said register, someone else is taking care of the register, of the deregister, of update. I just need to know that I need to make this change when the status happens. I just have this update inside me. As an observer, I just have update. I don't have anything about the subject. Loose coupling. Okay.
Yeah,
We'll discuss it more. We'll discuss it more. Let's quickly discuss one more design pattern for 10 minutes. Let me introduce it. Tomorrow we'll pick it up more. Okay? Yes? Can everyone calm down for 10 minutes, forget everything and focus on the new concept that I'm going to cover? Yes? Yes? Full focus, guys. Again, important concept. So please, today we have covered some really, really important things like observer design pattern was very important. Singleton, both of these are probably one of the most important design patterns that you should know. So please, if you got lost anywhere, rewatch the recording, ask the questions on Discord. Let's look at the next thing that I'm about to say. Okay. Now, see, as users, we send a lot of requests, correct? Like there are a lot of requests that happen in any system. Like we have sent a request, this happens, that happens, correct? So let's talk about that. Is everyone with me? Can I get more yeses? I want everyone awake for 10 minutes. Come on, 10 more minutes. I want everyone awake. Yeah, thank you. Cool. Thank you so much. Let's talk about a case. Everyone can think about it as homework. Now, this is the case. Okay, that we are designing, say, Lucid chart. What is Lucid chart? You remember we used it to make UML, or we are designing, say, Word doc, or say any text editor. Basically, any editor of this kind. Okay. Now there are a bunch of things that we can do. Like in there are a bunch of things like say we do save, we do say copy, we do say click, we do say hover, we do undo, we do redo. These are basically some of our commands that we run, correct? Yes? Yes, guys? Everyone? Yes? Okay. Modi ji and all will happen later. For now, focus over here. So there are commands, save, copy, click, hover, undo, redo. Now, the thing is, suppose I ask you that how are you going to implement the undo, redo feature? How are you going to do undo, redo? Okay, this is the question that I'm asking. How will you do undo, redo? Now, the point is that every command that you are executing, you need to store it somewhere. Yes, exactly. Meenakshi said a stack of actions. Or basically, you need to store every command somewhere. You need to have a log of commands. Correct? Say queue or a log or whatever you want to say of commands. Right? And many times it will happen that this command that we have, like save or undo or redo, we would want to take some action based on it. That, okay, this is the command and we need to do this, this, this. Basically, what I am trying to say, I will show you in the code, so don't get confused. What log means, I mean a queue or log. Log means writing it down, not like log means, put like logs wala logs. Okay. Now, I might want to send these commands in, say, some parameters and functions. Like, for example, I have a method and I say that this was the command that was called take some action based on this. Yes? So, what I'm trying to do is, I am trying to have these commands. I'm trying to store them somewhere. I'm trying to parameterize them. right? Basically, the main thing that I am trying to do is encapsulate the command as a request, as an object, sorry, as an object. Commands or requests as an object. And this is what command design pattern does. We'll talk more about it tomorrow, that exactly why do we need it, what problem is it solving, how are we making it, like how is it making our life better. But does everyone understand that there are some commands that we need to treat them as objects? Okay, basically, see, I am doing some click, that save or copy something or do something else. Okay, there's one very good case that I would like to say. Everyone focus. So currently, suppose I am saving by a save button. There's a save button, I'm saving from that. Now I want to reset my shortcuts and I want to say Control plus S. Whoever is talking nonsense in the chat, no, if I get today feedback that I was not able to focus because of the chat, you wait and see. I can see so much nonsense happening in the chat, guys. Just focus for 2-3 minutes, no, please. Yeah, thank you. So this is the case that I am talking about, that there is a save button. And now I want to change my shortcuts and I want to say that if I do Control S, same action should happen. And I should be able to say that if I click this or if I do this, if I change my shortcut, the same command should be triggered. The same action should be triggered. And I should be able to store my commands, like say command 1, command 2, command 3, like this. And if I want to do undo, I can just undo, and I can redo. Yes? Makes sense that what problem am I trying to solve? Yes? Guys, yes, no? What problem we are trying to solve? Understood a bit? People are saying no. Okay, some are saying no, some are saying yes. It's fine. Anyway, we are going to discuss it tomorrow again. Let me give you some context, some more context. For example, now there is a command. I am going to make it an interface. I am going to repeat, guys, relax. Now, there are different kinds of commands that are going to happen, right? Like, for example, there is a save command, or there is a copy command, or there is a highlight command. Now, my main point is that whatever action I have to take, the command, the request, I am treating it as an object. That is it. That is the crux of the entire design pattern. Does this line make sense? That whatever request I am doing, I am keeping it as an object. That this is the request that came. Does this make sense? What is the behavior? What is the command that came? I store it as an object. Does this make sense? Yes, no? Just this one line. Yep. Whatever command came, I keep it as an object. So this is my interface. These are some specific commands. These are my concrete commands. Save or copy or highlight. Okay. These are my different kinds of commands. Make sense? Yes? Okay. Now see, all of these commands need to be executed, right? So all of them needs to be executed. So I am going to have an execute function in all of them. So in the interface, essentially, I'm going to have an abstract method execute. Okay. Please mute yourself. Okay, I have done it. Cool. Execute is an abstract method, and I have to have execute in all of the commands. Make sense? Yes, guys, why are you leaving already? Please speak. Oh, we have to discuss. This is important. Yes. So there is a command, there is execute. There are specific commands, there is execute. Okay. Now this is one thing. Now, obviously, there is someone who's going to be invoking the command, right? Who's going to be calling the command that I have done this, I've done this, I've done this. Correct? Suppose menu option is there. I am pressing it, right? The button is there. So that class is going to be called an invoker. That is an invoker. There's some invoker. Correct? And based on this command, we need to take some action. Right? Who is going to take some action? Receiver is going to take the action. That receiver execute something. Now, on what is it executing? Like, for example, we have a text and this was highlight. So receiver is going to highlight this text, or copy command is there. It is going to copy this particular text, or save is there. It is going to copy this particular text. Invoker class is different. Basically, you can think of it like menu options are there on this, right? And guys, this is actually a very real example. In this GUI, this is a very common example. Whenever you are asked to design GUI, you can use this command design pattern because there will be a lot of commands that you will have to deal with. So there are buttons, right? So when we click the button, you can think of it like on click method that will invoke this. So that will be your invoker, right? So that will be your invoker. There will be commands and your command will tell your receiver that you need to take this action. This was the high level thing. Tomorrow, we will look at more examples and we will look at the code properly and discuss this in detail. Yes? Excited? Bit? Yes? This design pattern is called command design pattern. It is also a behavioral design pattern. Okay? Because we are basically commands about behaviors. Yep. Yes? Everyone with me? Okay. Now I am going to let you guys unmute yourself and whatever discussion you guys want to do, now you can do.
Hello, Kirti.
Hi, Kirti.
Hi. For this observer pad, sorry.
Observer or command?
No, sorry. For observer builder pattern. Yeah, sorry. For builder pattern, you mentioned about there is we are not forcing that each every
Concrete
method has to
builder
be,
to have to build something that they need, right? Yeah.
So, but we so as we are using the interface, then the who is implementing those interfaces, they should implement something, right? So
okay.
if
So what I said was that there is concrete builders are what? Dell desktop builder or HP desktop builder or Sony desktop builder, right? So they have to build. What I said was that suppose there is an iPad builder. My iPad builder should not be forced to have build keyboard or build mouse. Does keyboard make sense for iPad or phone? No, right? Does mouse make sense for phone? No. My point is that you should not be forced to implement something that you do not require. But my Dell desktop requires it. They should be forced. The entire point of interface is that you're setting a contract or a template that you have to implement these methods. But ISP says that you should not force anyone to implement something. Make sense?
Yeah, so in that case, we have to create a separate interface for that. For iPad.
The way you deal with it will be different. The point is that do not implement the same interface and have a dummy function. What my point was that don't add a dummy function. Say some people will say that because now I have a builder ready, I will just add an iPad builder and I will say build keyboard, but I will do nothing inside the function. That is a dummy function that I have just I have defined it, but there's nothing happening inside the function. I've just added a log. Nothing is there inside it. That is forcing to have a function that you do not need.
Got it. Thanks.
Yep. Okay.
But what if you had to implement iPad and it had a lot of overlapping things? So you might end up like repeating yourself, right?
That is why I said that before you start designing, you need to know that what will be your use cases. If you are designing iPad, laptop, all of this, I would probably suggest that it is a family of similar products, iPad and laptop. So you could have abstract factory over there. That is one possible solution. Some people are saying have different builder. But now your cross questioning is correct that if I have separate builder, there's going to be a lot of same things that are happening, right? So how can you make it extendable? This is a good use case that we should be discussing about. Okay, consider this as homework. If this is your homework, that there's desktop builder also, there's iPad builder also. Now in desktop builder, what are the things you have to build? You have to build RAM, processor, SD, graphics card, keyboard, mouse, all of that. In iPad, most of the things are same, but keyboard doesn't make sense, mouse doesn't make sense, right? So how would you design this? Now this is like one design problem. Take it as a homework and let's discuss this on Discord.
Yeah, Kirti, say around the same lines, what you just said before this course, my understanding about the builder design pattern was that the typical the canonical Subway burger example where they build it part by part, like you add whatever sauce you want and stuff like that. But after your explanation, I thought that is not a good fit for this design pattern, the builder design pattern, right? Because there you need to have the same creational mechanism, but in case of Subway burger it is about pick and choose.
See, you remember the chaining method that I showed, that in the chaining method you can do dot this with this with this with this. So there you can choose that I do not want to add this. If you want to do like that, you can. It is not a very typical example of it, but it is still a good example because you are still configuring. See, my point is you can configure that. You remember I showed that. Let me show it again.
Yeah, but in that case there will be multiple directors, right? Because every customer will have a different direction to create. That's agreed, no?
Yes, yes. So as I was saying yesterday, it is not necessary that you will have a director. Like you can have something like, like your main itself can act like director, or basically wherever you're triggering it can be your director, right? So that is one way to look at it.
Okay.
So you could do something like burger.make, and then it will have like with sauce. That is how you must have seen, right? That with something, with something, with something. Now you can say that I do not want to add this. I'm going to do this, dot this, dot this. So that is one way.
Okay.
But then, yeah, there will be multiple directors.
Yeah, and the other question what I had was about the singleton class for early initialization, what you explained, and then you said that static classes are not there in C++, but we can still have static objects, no? or global objects, and that would be as good as early initialization, isn't it?
If you have a global object and you create it
Or a static object.
Static object. What do you mean by static object? Like
Means
in
let's say there is a
C++ 11 that you're
class and
saying
you
that,
create an instance.
like
Static.
you're saying, like in C++ 11, you can create like a static that and you can go ahead with it, right?
No, I mean even in C, right? Static objects. Static objects. Not C++ 11 also. Just create an instance. It is as good as I think early initialization. No.
Just create one instance, but you have, yeah. So basically in the early initialization also, I'm creating a static instance only, no?
Yeah, but global object or static object would be same, right?
You can, yeah. But the point is that you have to make sure that, firstly, it is declared only once. And my point is also who can remove it, like in, where you are creating, who can delete it also. All of that
Correct.
also, I'm thinking about it, yes.
Okay, yeah, fine.
Like if you make it global and like what access you're giving, like are you giving the access for anyone to make like, to delete it also, I'm thinking.
Yes, such fine-grained control can be given only through class, but I was just thinking conceptually it's possible to create a static object and that would be as good as Singleton. That's all. Yeah, thank you.
If someone's asked in the beginning, like, can we say every static class as a singleton? Can you please explain about that? I didn't get.
In terms of C++ or Java?
In terms of Java.
In terms of Java.
Yeah.
So in Java, as far as firstly, there is one synchronized thing in Java, right? So you have a static member variable, and in my function itself, if I make it synchronized, I make it thread safe. That is one way to go about it. If you have a local static variable, you are taking care of the thread safety, so you can take care of that also. You can have a static class also. It is called Pillbook Singleton. I do not remember the name. I'm just looking at it. So there you can do like static final singleton instance. It's called a Pillbook Singleton. So basically, when you make a static class, that you can use in Java. So you can read about it more. There are more ways also. There is like you can create an enum and handle the serialization. There is something folder idiom also. As I said, there are many ways of implementing Singleton. It's not just one way.
So one thing I wanted to confirm, like all the things today we understood were like weather app, traffic light app. Those were a part of behavior design pattern, right? Then what is this observer design pattern?
Observer design pattern is behavioral design pattern. So behavioral is a so creational. In creational, we learned factory, abstract factory method, all of this, right? Similar to creational, there are two more types, behavioral and structural. So structure we'll do later. We finished creational, all the design patterns that we did, simple factory method, abstract factory, prototype, builder, Singleton. We did 6 creational design patterns. Now we have started with behavioral design patterns. We did we did observer, and we started with command. Tomorrow we'll do chain of responsibility, iterator, and we will try to also cover state.
Okay, so behavior is the second type, and inside behavior we have the observer and the command type, and all these weather app, traffic lighting app, all are a part of observer type, right?
And those were examples of observer design pattern. Yes.
Okay, thanks.
So Kirti, again in this observer, this one, observer defined pattern, let's say for the same example, magazine thing, subscribing and subscribing, if we let the observer do that through third party, so can we say that this is observer defined pattern? If we let it do third party, let's say a main class only, let's say assume main class is third party.
And that's what we are doing, no? That we are, okay, you are saying let observer only do it. See, the crux of the observer design pattern says that that subject should have a list of observers. Whenever the state changes, observers should be notified. Exactly how detaching is happening. Okay, you can make it like you can do it in another way, but the standard way is that those 3 functions are there in the subject: register, deregister, and notify. That is the standard way to go about it. You can obviously change it. The crux is that when the state changes, these observers should be notified. If you're doing that, then you can consider it as an observer design pattern. But the guideline of observer design pattern itself is that there should be loose coupling. So please remember that. Yep. Makes sense? No?
Yeah, it makes sense, but isn't it like to main if we are going through third party, isn't it loose coupling?
If you're going through third party, still you are able to if you're going through third party, but you still have the knowledge of the subject, right? You are still able to access the subject.
No, I have the knowledge of third party, and third party have knowledge of the subject.
That is what we are doing only, no? That is what we are doing, because when we'll be triggering unregister, obviously our main should come to know that, okay, this person has triggered unregister and we should be able to do it. Obviously, like observer should be able to do it. Yes, that is. Yes. Yep. Any other questions, guys?
So Kirti, actually, we are going for command pattern. So you mentioned execute method that we are keeping in the interface, and that will be implemented by other commands. So here my question is, for save, suppose there is a draw method. So for draw method, there is a position required. So position is the parameter XY coordinates. So for other method like open method, so it requires file name as a parameter, but in execute there is no parameter. Okay, but so if I want to do undo thing, so these parameters are required.
So I will show you the code tomorrow and we will look at it. Yes?
Yeah, fine.
Also, Samya is asking, can you explain how factory pattern is different from command pattern? It just seems like the same from code point. See, Samya, the main thing that you have to remember, in factory, we are doing the creation. In command, we are talking about the behavior, different commands, right? That is the main thing that you have to keep in mind. And also we look at the command code and everything, so it will get clearer. But essentially, you should remember factory and command. Factory, we are creating something. Command, we are talking about the behavior. We are treating a command or a request as an object, right? The request is the object. Okay.
So one thing I was getting like overthinking kind of thing. So this factory thing, right? It is only for creation of the objects, or we can create anything. Like, can we go and create builders out of it? I mean, just out of the.
Builder is also an object only, no?
Okay. Okay. So yeah, then yeah.
You can combine multiple design patterns. Actually, now you guys can start thinking about it. Can you combine singleton, builder? Probably I can say that I want one instance of the director, or say one instance of abstract factory. You can think about all of this, you can try combining singleton with others, or abstract factory with others, or builder with others. You can think about it. So factory, essentially, we'll see not just with creational design patterns, we'll cover strategy design pattern also next week. So you will see, we will in a lot of cases, in fact, if you see my Uber, Ola, Swiggy, Zomato wala design, I have combined factory design pattern with strategy design pattern. So we'll also look at that also, not just within creational design patterns also, but a creational design pattern with a behavioral or structural also. How can we combine them?
Yeah, good. So that's what I was thinking. So for example, in today's case, right, when there was a builder of desktop and there was a builder of iPad, right? In that case, in order to implement, what I was thinking is we can create an interface of builder of electronics, which could have children like builder of desktop and then builder of iPad, and these builders could be generated by a factory, like something like that.
Right. So I was actually suggesting in starting, right, abstract factory plus builder, something like that. So I would really suggest, if you do not get time to write the code, at least draw a UML, like a class diagram, that this is the class, this is the class, this is the class, and show it to me on Discord, right? I would love to see that, if you can try implementing.
So in interviews, do we need to run the code and show the interviewer, or like is writing the pseudo
In
code?
LLD, you have to you have to write some part of the code at least. Like in my interviews, I've like implemented, say, 1 or 2 design patterns. See, factory will take you what, 5 minutes? No, if else condition, you have to just put in another factory. Singleton will take you another 5 minutes. You just have to add double check locking, right? So you can make your code running very easily. In fact, so in LLD, you are expected to write running code properly.
Okay, thanks.
Kitty, I have one question. I have not thought through this completely, but for instead of singleton, why can't we use like one class with all static methods? Let us take logger. Like we can have a logger class with maybe some log info, log error, that kind of static methods, and call that wherever we require, right? In that case, it will all use the same instance, and like there won't be any like this multiple instance, and there won't be any confusion, right?
Essentially, aren't we doing that only? But singleton is about how you're creating that one instance, right? Like you're saying you're just going to create a static method, and that we are doing over here also, but the getter is the static. So you're saying you want to create all of the, like, every log function that you have inside the log, you want to make it static. Every inside the configuration, whatever they want to create it static. Isn't that a lot of work? Like, rather than creating the instance itself as static? Like, imagine we are talking about logger or config or DB instance. Every function that configuration or logger or DB instance has, you're talking about making all of the functions static.
Yes.
Isn't it better than we make the getter as static and we deal with it?
Okay, it is. Is it like then only for making it simple to code? Because I don't
Also,
see use
see,
case
not
where
just simple to code, but you also have to think about extensibility, maintainability. You're making sure that you want the behavior like this. Tomorrow, always try to think of this. Okay, when you think that you can do this, think of it like this. 5 years down the line, you leave the company and someone else comes, sees 5 static methods and goes like, I don't know why they wrote static. I will not write static. And they go ahead and write a function which is not static. What is going to happen then?
Okay.
No, it's like even if you have everything static. So suppose in the logging, if you have a file which is getting logged, so that will be as a member, right? So you have to put that as static. But suppose now 4 other people are creating the object out of that, and other objects can change the file what it is pointing to, right? Even if it is static.
Okay. Okay.
So if
Yeah.
it is just one single object, hello.
Yes.
Yeah, we can hear
Yeah,
you.
if it is just one single object, means there will be other objects cannot be built. Is that the point? Singleton.
Okay. Okay. So we are protecting the parameters and like something that should not be changed by everyone. I mean, like all the clients.
Yeah.
Okay. Thank you.
Any other questions? Yeah.
No, I'm just talking about the singleton, that keeping the members common to all the instances who actually trying to create the singleton object. So for all the classes, or so it is common object who can actually, so others can deal with that. So it has common values which is stored. So if you don't use singleton, then it will create multiple instances, and it will have each object have their individual values. So to avoid that, actually singleton is mainly used.
Yeah. She was asking in terms of like logger and configuration and all of that, I guess. So that is why.
Yeah, I was more talking about like we'll not have the option to create instance itself. We'll not have a constructor. It will be like private. But all the functions and properties will make a static and directly use them. But yeah, I understand like whatever reasons explain.
Any other questions?
Yeah, in your quiz, you had asked this question about pool of objects, right?
Yes, pool of
So the thing is, this pool of objects, there is another question called multi-ton. Multi-ton classes where you have a set of instances which you can control.
I was about to cover it. I forgot to cover it today. I'll cover it tomorrow.
That's okay, but in your quiz, that was not an option, but the answer was, I think, some other pattern, right? Prototype or something where you control the.
I don't remember the question. What was the question?
Yeah, the question was that which is the best best candidate pattern for having a pool of objects.
Pool of similar objects, I think, based on
Right.
something. So my point was that there's a prototype and you are trying to copy it. So that is why I meant prototype. Like it is obviously on the basis of what we have learned so far, right? That is not there in the option. How will you select it, guys?
It's like if once you create object, you keep create another objects using prototype. You are cloning it and then keeping a cache of all that objects.
Yep. Okay, guys, go sleep because I want all of you to show up. Already from yesterday, today the attendance was lower. So I want everyone to show up tomorrow, 9 p.m. Let's finish behavioral design patterns also properly. Yes. Thank you so much for waiting and thank you so much for being so attentive and nice and sincere. Thank you. See you tomorrow. Bye. Good night, everyone. Take rest. Sleep well. Thank you. I love that you guys like the class. Thank you. Bye.